Hi folks, welcome back. In the last video, we created a NextJS app that authenticates with GitHub using their OAuth API and sends a token down to the client. In this video, we're going to install Isograph and use that token and Isograph to make network requests to the GitHub GraphQL API. The point of this video is to show off the developer experience of using Isograph and just generally give you a sense of what it's like to create an app using Isograph. In particular, what we're going to do is we're going to get a list of repositories and then add and remove stars from those repositories. I'm joined here with my friend Lenny Garcia Crespo. Why don't you go ahead and say hi?
Hey, hello everyone. Happy to be here next to Rob. Yeah, to check this out. It's really cool.
Awesome. Let's go ahead and get started. Okay, so first thing we're going to do is we're going to take a look at the Isograph Quick Start Guide, and we're going to follow this. This guide takes you through creating a new Next.js app that uses the publicly available Star Wars API and builds an app with that. We're going to use a different API, so we're going to pick and choose from it, but we're roughly going to follow this guideline. Okay, first things we're going to do is install the compiler, Babel plugin, and runtime.
You wanna give a high level overview
absolutely.
of what does each package kind of does?
Yes. So the compiler will run in watch mode. So now that we've installed it, yarn iso is a command that we can do, or yarn iso -- watch. This will scan our code base for isograph literals, which are iso followed by a parentheses and a backtick. You'll see a bunch of those. And for each of those, it'll do something. It'll add a field or create an entry point. And from each of those, it will generate a bunch of files. The Isograph runtime will use those files and do stuff like make network requests, write that data back into the store, and read that data out and render components. The Babel plugin basically converts these ISO literals, the ISO followed by parentheses followed by a backtick, into require calls. So it sort of improves the developer experience of the overall thing. We'll go into a lot more detail as we start doing this. Okay.
Sounds good.
So now let's go ahead and install or create a Babel rc.js. This allows us to use the Babel plugin, or this tells Next.js to use Babel. Okay, cool. So now let's go ahead and restart this, and you'll see here it says, I don't know why it's doing that, but here it says disabled SWC as a replacement for Babel. All right, why are you giving an internal server error? Let's go ahead and try yarning and... Oh, well, the reason it's giving an internal server error is because the Babel RC also expects the isograph.json file, isograph.config.json file to exist. So this tells Isograph, and it also tells the Babel plugin, where to find your components, where to find your artifacts, and where to find your schema. So in particular, we have to specify a project root and an artifact directory and a location of our schema. So let's go ahead and copy this. We can use this one right out of the box. It works for our use case. Isograph.config.json. And now, if we refresh, well, cool. At least nothing breaks. Off to a great start. Okay, next thing we're going to do is add aliases to our tsconfig.json. We're only really going to use this @iso alias. This one's a best practice for, if you actually need to import some types from the generated files. I don't think in this demonstration we're going to need that. We're just going to use this second one. So let's go ahead and copy this. Well, copy these two lines here and load our tsconfig.json. Find these paths. So, oopsies, I can do this. Awesome. And interestingly, it does not auto-format this. That's very interesting. So this adds two aliases. All right. Next thing we're going to do is disable React strict mode So inside of our next config, we want to go ahead and disable React strict mode. The reason for that is that React strict mode, when it renders a component for the first time, it will mount it, unmount it, and then remount it. The underlying thing that we're doing here is we're generating some state during the initial render, not during the mount. So unmounting it cleans up that state that we created originally, and then remounting it replaces that state, but it doesn't actually undispose of it, if that makes any sense. So for now, the underlying APIs are not compatible with React strict mode. I think that this is something that I can work around. Basically in dev mode, it's going to require that you just make twice the API calls in some situations. That's okay. I just haven't done it yet. So for now, Isograph incompatible with React strict mode. Okay. Next thing we're going to do is we're going to download the schema to schema.graphql. One thing you'll notice before we do that, if we run yarn iso --watch, it'll tell you, hey, does schema.graphql exist? Well, it really doesn't. So let's go ahead and copy link address, and then we're going to go ahead and curl it and, oopsies, curl this and write it to schema.graphql. Now, if we run yarn iso watch, we see that the ID field must have, well, we get further along. That's nice. The ID field on this type must have this type ID. So basically, at this point in time, it's telling us that the GitHub GraphQL schema is not ideal because it has some ID fields which don't have the right type. Isograph makes a lot of the same assumptions that Relay does with respect to IDs, and so it just wants to tell you that, like, hey, you might be doing something wrong here because we're using this ID, which is not guaranteed to actually be an ID, as a key in the Isograph store. Okay, so it tells us what we can do. We can suppress this using the onInvalid. This is actually a typo, so it's onInvalid ID type config parameter. Let's go ahead and fix that. So if we go to the Isograph config, add options, onInvalid ID type, and we're going to tell it ignore because we are YOLOing it. Now we run it, and it works. Excellent.
Nice.
So the Isograph compiler isn't doing very much right now. It's writing a bunch of artifacts, as you see, 260. Those are unused right now. And by the time we actually release this, like make the release of Isograph, which is when this video is going to be published, that shouldn't happen anymore. But the point is, right now, it's not really doing very much, especially nothing useful. Okay, so what are we doing next? Next thing we need to do is to teach Isograph how to make network requests. So in particular, we need to define a function, makeNetworkRequest, that takes a query text and some variables and returns a promise of whatever the response is. So in this case, we can just go ahead and copy and paste this directly. Actually, we can just copy this whole thing and write this into our app.tsx file. And then we just want to replace the API with, I actually don't know what the GitHub GraphQL API endpoint. I believe it's this one.
Yeah, looks like it.
Yeah. If not, I have another project available that I can find out exactly what the thing is. We also here want to pass a bearer token or an authorization header. Let me see. Does this have information about it? Yeah, authorization, it's going to be of this form. Authorization, bearer, and then token. Authorization, bearer, and then token. We don't have the token right now. Okay, so let's go ahead.
I think we also need a space between bearer and token.
Thank you, good call. So let's go ahead and make this a function of a token. So make network request function with token. Token is a string, and it just goes ahead and returns this guy. Okay, cool. So now this app, where did we put all the other stuff? This main app. This main app is actually where we need to put this this stuff here. So let me go ahead and cut this. Just replace this with what it used to be. This will be fine. All right, so now we go back to main app. Here, remember main app, you don't want to export this guy. So main app here has the session, and that is going to have the token as part of it. So what we can do here is let's say actually main app inner. And we're for a little bit of clarity, we're just going to pass a token, and that token is going to be a string. We'll call it access token actually, because I think that's what it's named in the thing. All right.
Yeah,
Token.
we also need to move it to the other branch, right?
What did you say?
To move it to the branch where we, like in the one above, I think.
Sign in with GitHub. Yes, you're right. Yes, excellent. Thank you very much. All right. And it's going to be session. It's probably access token here, but we can, I think this is going to be any typed. Yeah, basically we haven't added the types to this to actually indicate what's there, but that's not necessarily related to Isograph, so I'm not super concerned. Okay, let's go ahead and render here and see. We sign in. Session has an access token. Okay, excellent.
Nice.
Okay, cool. So we are probably passing the access token correctly to main app inner. Inside of main app inner, what we want to do is create an environment. So we are memoizing this because if this function gets re-rendered, we want to reuse the same environment. And okay. Access token here. Awesome. And we don't want to, if we keep on recreating the environment during render, we're going to lose all of our data. So we want to memoize the environment that we create. We also don't want to create it at the module scope, because then NextJS will reuse that environment for multiple network requests, potentially coming from different users. So that's not good either. So we want to create it in a component using useMemo. Okay, the next thing we want to do is load that environment into context using the Isograph environment provider and render some sort of our actual app. These are poorly named components. I didn't really plan the names of the components very well. All right, the return, let's see, return hello from actual app. All right, so let's see. Yeah, we don't need this. We don't need this. And let's just make sure that stuff works. Hello from our actual app. Awesome. So cool. Right now, inside of our actual app, if we do const environment equals use Isograph environment, we can console log that and see that the environment that we just created is available in context. Let me see, use Isograph environment. Okay, so now here we go, we refresh, we see an environment, cool, it's got a store, it's got a network function, it's got some other stuff that, you know, isn't super relevant to this specific video. Okay, awesome. Now that we've done the setup, let's go ahead and actually create an Isograph component. Okay, so remember in our Isograph config, we said that source components is our project root. So anything, any function in here, or any file in here is fair game. Let's call this home route, or I mean, we'll call it repository list, because that's what we're building. Okay, so in order to create an Isograph component, you need to do two things. You need to call ISO, which is a special function that Isograph gives you, and you need to export the result of that function so that the Isograph runtime can actually go ahead and grab that field, that component, the thing that we're defining here. So let's go ahead and do that. So we're going to import ISO from @ISO. Remember, this is the one that we defined in our Babel RC. So one thing that you'll notice is, sorry, not in our Babel RC, in our TS-config. You'll notice is that this @ISO actually comes from this source/isograph. Oh, oops. It's actually source/component/isograph, because we are doing something slightly different than the demo, or the demo is slightly incorrect. We actually have to put it here. This @ISO file comes from this __isograph folder, and it is, well, let's just go ahead and load it. It is generated for us. So it is specifically this thing. And as we generate more Isograph types, Isograph fields, this file will get bigger and bigger, and the specific type of the Isograph file, of the Isograph function that we're calling, will be provided to us. That's going to make a little bit more sense once we define repository list. Okay, so here I'm going to export const repository list equals ISO, and then we're going to do this. Field query.repository list. So query is is a type in GraphQL, and we're defining the name of a field named repository list on query. So this is a field that doesn't exist in the GraphQL schema, but we're adding it to the schema, if that makes any sense. So let's go ahead and see what happens here. Now we have compiled one resolver. And yeah, if we pass it a function here, so actually let's go ahead and tell Isograph that this is a component. So we're going to pass it a function. This is the function that actually gets called with our data. Let's call it repository list component. And it's going to take props. And now you'll notice that props, let's save it. And props has this data field. Doesn't really have anything on it. Okay, but at least it knows that that props exists. Okay, so in order to add some fields here, what we want to do is go ahead and select things here. If we go to the schema.graphql, we can find type query. There's a viewer field, or a viewer. There's a viewer field here. Let's go ahead and select that. We'll select viewer, and on viewer we'll select, it's a user, so probably name. Yeah, cool. It did correctly. I did remember the name of the field correctly. So now if we go here, we'll notice that we have props.data, and then we hover on that. Cool. Looks like we have a viewer object with a name field, and the name is nullable. Okay, so let's go ahead.
One question regarding like what the compiler says there. Like it says like one resolver. Like what does resolver mean?
Yes.
Is it like the Isograph literal, like the new field that we are creating, or?
Yes, that's exactly right. Resolver refers to any Isograph literal that is defined with this field keyword. All of the names need to be cleaned up. So it's sometimes like there's like a little bit of contradictory naming in the Isograph project, but it refers to a client-defined field. So in this case, we're defining a new field called repository list, and we're defining one of those, and that's what's referred to by resolver in this case.
Good. And
okay. Yeah.
Another question there, like what is that syntax that is like similarly looking like GraphQL but not quite? Is that like a specific to?
Yeah, it's specific to Isograph. So the reason that it's not GraphQL is twofold. One is that there are certain limitations to GraphQL that I don't particularly like and that aren't like very well suited to what the Isograph project is doing. So in particular, you can imagine a subcomponent as corresponding to a fragment spread. in Isograph, what you'll notice is that all the subcomponents are their own properties, as opposed to sort of being part of the parent object. There's just a lot of little things like that that I kind of dislike about the GraphQL syntax. And so I just said, whatever, let's build something that is right for this project. Secondly, right now, Isograph only works with GraphQL. But in the long term, there's no reason that it should be limited to GraphQL. Also, there's no reason it should be limited to React. There's no reason it should be limited to JavaScript. When Isograph starts expanding out of targeting GraphQL and React and JavaScript, it will make more sense to have a syntax that's more closely aligned with what I want, as opposed to, or what the Isograph project needs, as opposed to a pre-existing syntax. So yeah, there's downsides to this. One of the downsides is that there's no syntax highlighting and all this kind of stuff. So there's just more work to be done as a result of having a new syntax. But I think in the long term, it's going to be worth it, so as not to be tied to the decisions that GraphQL makes, which might be right for the GraphQL project, but Isograph is a different project.
Yeah, that makes sense.
Excellent. Okay, so now let's go ahead and take a look at this iso.ts file. This here is new. What this tells us is that when we use this iso function, if it starts with a, if we pass it a string that starts with field query.repository list, then the return value of iso is a function that passes this type, field query repository list, which is in the generated file for query/repository list. So the Isograph compiler, when you saved, it noticed that a file had changed. It regenerated this reader.ts file, and it regenerated this iso.ts file. This reader.ts file includes, here's the type of the parameter that we're going to provide. Importantly, that includes data, viewer, name. And iso.ts said, hey, if you call iso with this string, then the parameter that we're going to give you has that shape. Okay. Next thing to notice is that all the other parameters right now are untyped. Like, a thing that I need to work on in Isograph is actually typing the other component props. But right now, every single other prop is untyped. I hope you bear with me. Okay. Excellent. So now we see props as props.data.viewer.name. Okay. That's sufficient. That's sufficient for this component for now. One thing we have to do, like, this isn't really doing much. It's just defining something, but like, we didn't modify our actual React app to do anything. So it doesn't do anything. What we need to do is actually fetch this component somehow. So let's go back to main app inner. Yeah. Or our actual app. Okay. This is starting to look like main app inner 2, main app inner 2 for real. I have similar problems with saving files in my documents. Okay, so we don't actually need this Isograph environment. All the stuff uses it. Calls use Isograph environment on its own if it needs it. Okay, so what we're going to do is go ahead and get a query reference by calling use lazy reference. Lazy here refers to it will fetch it during render. Okay, so use lazy reference takes an iso literal. So once again, let's import iso from @iso. This iso literal, instead of being a field, is an entry point. So we're going to say entry point and then the name of the field that we want to use. So query.repository list. And then the second parameter here is the query params. Our query takes no query params, so it's an empty object. Okay. Now, if we go back to this iso.ts file, you'll notice there's another thing, which is this has now shown up. And now, so the type of this iso literal is the return value of this generated file. It is actually this thing right here, this Isograph entry point. Okay. An entry point is a query is, most importantly, it includes the query text. So now if we render the app, Isograph will know to make a network request during render using this query text. And if we take a look at that query text, you'll see that it is selects the viewer, the ID field is automatically selected by Isograph, and the name field. Okay, so now let's go back to the app and take a look at what's going on.
Is just to clarify, is the ID like is this similar to what Relay does? Like the ID is used to cache the things in the store.
Yes,
okay.
Exactly. We see that we've made that network request, and yeah, that's a great transition to what I wanted to talk about next. So if we set window.log, let's see, type of window not equal to undefined, so that NextJS doesn't complain, window.log equals true. If we do this little hot little secret, you get a bunch of logs on the back end. So now makes the network request, gets the response, and then it normalizes. So this is the result of the store after we normalized. So in particular, we saw that the network response, oh, I guess we're logging the wrong thing. That's funny. Oh, yeah, we're about to normalize. We tried to normalize this object here. So we got a viewer with this ID, starting with MDQ. So inside the store, what you'll notice is that now there's a key starting with MDQ, which is, the value of that viewer. It's got the ID and it's got the name. So yes, exactly. These IDs end up keys in this global key value store. Well, global, not it's part of the environment. You can have different environments if you need one, but like basically global cache of all the network data we have ever encountered. So
cool. Yeah.
In particular, that's why it's important that the ID field is an ID type and is globally unique, because otherwise you might write two of the same objects into the same location in the store, and we don't necessarily want that.
Is there currently no way on Isograph to specify, to customize, like
Not yet.
similar to what Relay? Not yet.
Not yet.
Are there plans?
Yes, there are plans.
Nice.
Everything is going to be customizable. And in particular, what field you use on which type is always going to be customizable. Okay, so let's continue. We go ahead and we got this query reference. We have to read it out. So let's go ahead and say const repository list. I mean, it's not really a repository list yet. Is use read. So use read comes from isograph/react. And this guy takes it's called a query reference here, but it's a fragment reference. Again, some of the naming needs to be cleaned up a little bit. And this gives us, this reads what's in this entry point, or like the result of this API call. And then if we actually return it, we render it, we can do this. Now let's go ahead and take a look. Let's see what's wrong. Sign in with GitHub. Oh, it's doing some sort of, yeah, okay, excellent. It's actually showing, this is actually a really good issue. So when we render repository list, it suspends because the data is not available. When it suspends, you go up to here, this Isograph environment provider. We go up higher, we go up blah, blah, blah. We end up at the very root. We get a suspense boundary, and when it unsuspends, it re-renders. Then when it re-renders, it recreates the environment. So what we actually need to do is call react.suspense fallback equals loading here, and we will avoid this infinite loop. This react.suspense fallback here will prevent this component from unmounting and remounting during suspense, meaning that we can keep the same environment, meaning that when we re-render and try to read from the environment after the network request has come back, we will go ahead and find the data in the store, and not continually suspend. Why is this interesting that you can't? It pretends it can't find it. I wonder why. Okay, so now if we refresh,
it worked.
It works. This
Nice.
This name comes from the backend. Awesome. Yeah, that's it. Okay.
Question: Is the return value from a use read from an entry point always a component?
No.
So can we assume that? Or
No, it's not always a component. The type will be whatever the type of this field is. So in particular, if we go to repository list and instead of making this a component, so we take out component here and save. Now props is like, shouldn't be any type. It really shouldn't be. Yeah, now if we just return, you know, something like this, now the type here, repository list, will be a string. I mean, it should be a string. I'm really not sure why it's... Well, now it's going to be a string. So if we refresh, yeah, ASDF is unrecognized by this browser. It's not a component anymore, so we can just return, let's just say, return repository list. Okay.
I see. Yeah. It depends on how it's defined. Yeah.
Exactly. So let's go back to, oopsies, what did I just do? Let's go back to doing this. Make this a component again. We need to, for components, we need to specify @component here because there's actually like some wrapping magic that happens when, you know, it has any type. I think it just, if I reload the window, it'll figure it out. Because this ISO file is regenerated every time, so maybe TypeScript just doesn't understand. Yeah, cool. Now it figures it out. Maybe it just doesn't understand because I keep on rewriting the file, so it's like gets confused by this pattern. You know. Okay. So let's go ahead and select a bunch of repositories.
Repositories.
Yeah.
Yes.
Okay, so if we go to the schema and we find type user, I think it's got a repositories. Yeah, it's got a repositories field. It needs a, we need to give it a last. Repositories last, and let's say 20. And here we'll select, I don't know, type name. Why not? Let's see if this, yeah, awesome. And let's go ahead and let's still select name. Why not? Keep that guy happy. And console log props.data to see what we get. Cool. Yeah. Cool. We see we got a viewer. We got repositories. Yeah, nice. We just get a repositories connection. So type repositories, repository connection. It's got a bunch of, we're just going to select nodes to get a list of repositories. And on each repository, let's select
a name, maybe?
Name, yeah. Let's just see if name exists. Cool, it does exist. Okay, awesome. And let's go ahead and do what we would usually do is return, let's do something like this. Data.viewer, oopsies, not data transfer. That's, oh yeah.
Drops, yeah.
Yeah, name, repositories, okay, and then we'll say props.data.viewer.repositories.nodes.map, and then it's going to be repository. Okay, and then we're going to return. Oh, we should probably select the ID here so we have a key. Let's just say div key equals repository .id. I haven't saved, so it doesn't know about that yet. Okay, let's save again. Repository is possibly null. Okay. If repository equals null, return null. Cool. Problem solved. And then repository. Actually, let's make this an unordered list, because then we can make these list items.
Yeah, makes sense.
Yeah. Like that.
So even if Isograph selects the ID automatically, we still need to specify it here in order to read it in the component, right?
Yes, exactly. The data that we get in the component is just the data that we select. Isograph will also itself select extra things that it uses, but it won't give it to you unless you specifically explicitly select the field in this Isograph literal.
Cool.
Okay. Now we take a look here, and we see a bunch of repositories.
Yay.
Excellent.
Nice.
Yeah.
So many repos.
Yeah. Wow. Am I... Okay. Let's see what happens if I pass first. Oh, yeah. Okay, so last are the most recent ones. Okay, let's keep that. I'm just... thought that I would see Isograph on there. Oh, because Isograph is not my repository. That makes sense. Isograph is the Isograph... is in the Isograph Labs GitHub. Okay, cool. Doesn't matter. So let's go ahead and... so now we have this. One thing you want to do with React is break things up into subcomponents. Let's go ahead and define a new component called a actual repository. All right, let's go ahead and close this. All right, let's call it new file repository. Yeah, just repository. That's fine. Okay, so import ISO from @ISO, export const repository, ISO, and then we'll say field, and then this type is repository dot repository. Okay. It's a little weird, but repository component. Okay, return hello repository. And then we'll make you a list item. Okay. And this function is not callable, and that's because... Oh, it is. It is. It's just not picking up the types. Okay. Yeah. Okay. I'll have to dig into what's going on there. But anyway, now it's callable. Now it gets the... Whoa, what did I just do? What did I just do? Now it gets the types. So props.data is empty. That's what we expect. Okay. So now, actually, let's just go ahead and fill this out with, name. And we'll just say, props.data.name. Okay. So now, if we go back to repository list, what you'll notice is that now, well, I mean, you won't notice this, but now we can select repository here. And this guy, now we no longer have name. This guy we can just interpolate. So repository.repository. And now,
nice.
Refresh here. What do we do? What do we... Unable to... let's see what's going on. No such file or directory. Repository.reader.ts. Pretty sure that exists. So let's go ahead and... Okay. Some stuff is a little bit...
file watching issues.
Yeah. I think part of this has to do with the fact that I'm experimenting with making the project root and the artifact directory the same directory. Those used to be separate directories, and maybe that overlap is causing some consternation for NextJS. Anyway, it works. We see this. And now one thing that we can do is take a look at the React DevTools and search for @component, what you'll notice is that every single component that we just defined in this way, first the repository list, and then each of the repositories is actually its own component. So this is not, this is not some facade where these look like separate components. They are actually components. And so in particular, if we go to the repository component and do something like const state use state, that's not how you set state. Anyway, let's just actually do something like is clicked, set is clicked equals use state false, right? Let's see. Okay, and then we have this instead, and we click on one of them. Cool, the state works.
Nice.
Yeah, so just a demonstration that these are actual proper components. So let's just go ahead and remove that because we don't actually care about that in this particular. Okay. So what have we done here? We've gone ahead and created a component which renders another subcomponent, and at the root, sort of where we're in a proper React app, we've gone ahead and connected React to Isograph by making a network request for all of the data that component tree needs. So in particular here, if we take a look at schema, the schema, type repository, allow update branch. Let's select that field. What you'll notice is that in the generated entry point, the actual query that we send out now includes allow update branch. So at the root, we made a network request for all of the data that this entire tree needs. And then when we rendered it, each component in this tree just receives the fields that it specifically requested, but none of the others. So this gives us something that's quite nice, which is that if you have 100 developers working in the same code base, independently modifying files, all they have to do is look at the file. They can reason about it locally. And if they add or remove a field from one component, it doesn't affect the data that any other component sees, even at runtime. So that means that every developer can feel safe just making changes willy-nilly and only reasoning about the component that's in front of them. That's nice because, like, at scale, you don't want developers needing to know, needing to coordinate things and slowing down the organization. And you don't want to have a situation where it's unsafe to remove fields from a query because somebody might be using it, or somebody might land a change at the exact same time that starts to use that field. And so in the long run, queries that are manually written tend to be write only or append only, because it's just very dangerous to remove supposedly unused fields. Not only dangerous, it's just a lot of work to do so. So because Isograph does that automatically, the query that we generate is the actual minimal query for this particular view. Awesome.
So when you select that field in the repository list declaration, that's essentially like in GraphQL terms, that's like spreading a fragment, but then at the same time, Isograph wraps all that data and packs it in a component that you can render directly.
Yes.
That's kind of like what's happening.
Yes. You can think of this repository thing, client field here, as corresponding to a fragment spread. But when we actually read this out, we don't see the fragment spread. What we see is an object, which is that fragment spread called with this data. Or, I mean, this function called with the data in that fragment spread. It isn't exactly like that. It's actually a component that when it's rendered will read that fragment spread and do that. But like conceptually, yes, it's the function to which the data from that fragment spread has been passed. Okay. So yeah, let's go ahead and expand on this repository component. And let's go ahead and add the stargazer count. I think it's, yeah, stargazer count. Okay. Stargazer count. Let's see. Stars props.data.star. I can save it. Okay. Gaze. Really? Like this thing, you know, takes very little time, but then this guy just takes a while to pick up on it. Let's try reloading this window. Cool. Now it's there. All right.
There it is. Yeah.
Yeah. Okay. So one thing we can do is notice that once again, NextJS just like can't keep up. What you'll notice is that my components have very little stars. You guys can fix that. I mean, my repositories. But in fact, we can fix that here by adding one star to each of these. Okay, so mutations in Isograph are done with basically by defining fields on the type. That when you call those fields, will execute the mutation. That's going to be a little bit more clear with an example. So first thing we have to do is define a schema extension. I think it's schema extensions. Okay, so let's go ahead and do that now. If we rerun, oopsies, if we rerun the Isograph compiler, it'll say, hey, does schema extension.graphql exist? It does not. All right, so let's go ahead and touch. Cool, now it works. All right, so schema extension. We're going to extend the type mutation. And we're going to give it, and I think it's called expose field. Let me just copy one of these because I don't remember all of the, yeah, here we go, cool. We give it this directive, expose field. Basically what this is saying is that on the mutation type, there's a field named setPet tagline. There's not, that's for a different project. And that field in its response has a field as a, I'm using the word field a lot. This is going to get confusing. Okay, so there's a field on mutation called setPet tagline. In the response of that field, there's a field called pet. That has a certain type. In this case, it's pet. And what we're saying is that every single pet is now going to have a setPet tagline function added to it that you can select. It's another field that you can select. And when it calls that, it's going to make the mutation setPet tagline with the parameters, with the pet.id mapped to input.id. So this is the mutation parameter, and this is the field on the pet. Okay, so this obviously doesn't work. If we go here, say, cool, invalid field and expose field directive. Yeah, something's wrong here. Makes sense. So let's go ahead and do this. Let's go load the schema, type mutation. I think it's add star. Yeah. Okay. So we're going to say add star. The path is going to be, so let's find type add star payload is going to be starable. And the field map is going to be, okay, so let's see. Type add star input. Oh yeah, it's called input add star input. Yeah, okay. And then this guy is going to take, we're going to map something to starable ID. Yeah, okay, that looks like I spelled it correctly. Okay, and then let's do type star. Starable? Oh, it's
Starable, yeah.
Interface starable. Yeah, okay, cool. It has an ID as well, so we can just go ahead and select it there. Okay. Is there a remove star? Is there a toggle star? No, just remove star. Okay, and then let's just go ahead and do the same thing for remove star. Awesome. So now on everything that is starable, that includes repositories, there are going to be fields called add star and remove star that you can select. When you read those out, they will be functions. When you call those functions, it will merge whatever you pass into it with this field map, or with the results of this field map, sort of, and will call the mutation for you. Okay.
So to clarify there, like in this particular example, we're saying that where are we saying that field? So I guess first I have a question, like where do we tell that add star and remove star can be applied in a repository?
Well,
or can we use it anywhere?
No, it's only on starable objects. So starable is an interface, and repository implements starable. Yeah, so if you notice here, it's gonna somewhere implement starable, right? So
Isograph validates that you can only use this field on a type that is compatible with the path that you specified in the mutation.
Yes.
That's very cool.
Yeah.
So my question was like with the last configuration field, like this mean that from ID to input, does that mean that when I call add star on a given repository, it will pass its own ID as the parameter of that mutation?
Yes, exactly.
Oh, great. That's really cool.
So this right here, yeah, so this is the repository.id, and it gets mapped to the mutations input.starable ID. So for example, yeah, actually we can see that because we selected these fields, we end up getting, I wonder if we can have add star. Yeah, actually we can see. So this repository add star file has been generated. Again, generated file, lots of stuff that that TypeScript doesn't know about. Doesn't agree with. So we need to clean that up. The point is, it has this reader ASD object, which knows I'm going to select this ID field off of this repository. And then when we call make network request, we call this include readout data function, which says variables.input is variables.input, variables.input.starable ID is readout data.id, and return variables. So then we pass those variables to make network request. So in a very manual way, all it does is take this ID, stick it on the input somewhere and create that input object if it doesn't exist, and make that network request with it. And what's cool about this is that we also now have these refetch functions. In this case, this is the mutation text that gets made, the query text that actually gets sent to the backend when we make this mutation. So in particular, why is it called? Oh, this looks slightly incorrect. This D star part here. Why is it? I feel like something might have been cut off. Uh-oh. All right. 90% certain that this is gonna. Why is that? Okay. This looks like it should be add star.
Yeah.
All right. Yeah. I wonder why it's doing that. Okay. Oh, you know what? It used to start with __, and I reverted that. I made it add star specifically, and it still has a substring, so it tries to take off the first two characters. So this is not going to work. But I'll record a follow-up video showing how it does actually work. Okay, so let's see. Now what we do, let's clear this out. We can make a network request. We can click on one of these guys. Where are you? Repository. Yeah, I guess we don't really know. Okay, I think there's a viewer has starred. Viewer has starred. Yeah, there's a viewer has starred. Okay. Okay. On click equals viewer has starred. If so, we'll call add star. We don't need to pass any additional parameters. We're going to call props.data.add star. Otherwise, props.data.remove star. All right. Why are you?
Again, like the TypeScript.
Again, I need to. Yeah, I need to reload. Okay. And this is props.data.viewer has starred. Yeah. Okay. So now, wow. Okay. Yeah. Let's go ahead and click on one of these. Let's clear this out. It makes a network request, and it throws an error because move star, that path does not exist. That makes perfect sense. Okay, let's see if we can manually update this really quickly to see if we can do this. Okay, so refetch 0. I think it's refetch 1. Okay. If we do call remove star, and we call this remove star. All right. So now we just need to look for move star here. Yeah, move star, remove star. Yeah, this looks okay. Now it looks correct. Okay, so now we can't like change any of our components because that will be regenerated. Wait, why would it call remove star? I think I just did the logic wrong here. If the viewer has started, well, then we call add star. Yeah. Okay.
Yeah.
Yeah. So okay, I do need to.
The other way around.
Yeah, exactly. And then let's go ahead and save this. And then this guy is remove star. Let's just undo those changes. And now it's back to being correct. Okay. So now, we're going to call add star. Okay. So we actually want to go ahead and look for D star. All right. All right. Yeah. Okay. I think that this is sufficiently fixed up. Okay. Let's go ahead and try to add it. Hey!
Yay!
Okay, so
Nice.
I'm gonna fix that like double underscore issue in the repository before the release. So for viewers at home, this will be fixed. Okay, so that's cool. It selected and it updated the star. But like with any mutation in GraphQL, we need to go ahead and manually select the fields that we need to, we want. So if we go here, we want to select stargazer count. No, wait. We just called it. Like, that's already done. So how did it do that? Well, the answer is that...
Magic.
Magic. Oh, Isograph magic. Correct. The answer is that the generated query will include all of the fields that are already on this repository object. So the mutation response into the generated query. And then that data will be merged back into the store, and so the stargazer count gets updated, the viewer has starred gets updated. I mean, the name gets updated in this case too, but like that's, so we're overfetching slightly. This needs to be a little bit more customizable, but for now I think it's a very sensible default. And what's nice about this is that it means that if we have some other component here, right, and this other component adds or removes fields to its selection, this mutation will always continue to work. It will just select the correct data no matter what. So if we take a look at this refetch, this mutation field, you see that like ... on repository, we select ID, name, stargazer count, viewer has starred, which is exactly what we selected in the other thing. And if we remove name here and save, we go back here, you notice that name disappears after the compiler runs and re-outputs this file.
Will it select all the fields from that component and then down?
Yes.
Is that correct? So if I add a field in repository list, it won't be picked up.
Oh,
then,
also
right?
Here. It will also select it here. So if we add name here,
okay.
We go back here, we see name shows up again.
Cool. So it kind of like figures out all the occurrences of the type, or how? Yeah,
Well,
okay.
when it generates the entry point, it generates like this merged query that actually ends, which is what the query text is generated from. And in that merged query, there is a point on which like there is this repository node, right? There's this repository. And all of the merged fields that are on that repository get added to the mutation. So if we had something like this, I mean, I actually haven't tested this, but this should also work. An identical situation here where you like, let's take away name, and then we do this. Then this guy also has name, even though it's coming now from, from something completely different, which is this section. But like it knows that this guy, this node here, is merged into this node here. Well, this repository object here is the same as this repository object because the paths in the query are identical.
Oh, I see. Okay.
Yeah. Aliases like this, they don't exist in the mutation that we send to the backend. Like everything is aliased, but not with a user alias, just with an alias that the that Isograph has generated.
Cool. Will it also merge fields if there was like some other field of type repository here, or it has to be like the same path?
Yeah, it has to be the same path. So if you have like this, like repositories last 10, like this is now different, right? So now we go to this guy and we should not see name there. Maybe name is coming from something else. Oh, maybe it actually ignores these, which is a bug. But it should not include name right now. But if we have something like, I don't know how else to get repositories in this GraphQL API, but if we got repositories in a different fashion, it would not include name.
Oh, I see.
There's probably just an issue where we ignore parameters in this situation incorrectly. So, yeah.
Cool. Yeah, like the DevX for mutations is so cool. Just calling a function, it cannot get any simpler.
Right? Yeah. I really want this to be a little bit more than just calling a function, because right now you call a function and just in the background somewhere, it makes an API call. So you don't really have a good way of, I don't know, suspending on that mutation or showing a loading indicator. So
yeah,
I need to think about this more. But in the long term, we definitely want to make this a little bit more integrated, I guess, with, React, or sort of like maybe get some sort of object that you can do stuff with, or see the status of the mutation or something like that off of. I'm not really sure what the best outcome is in this situation. So I'm still thinking about that. And if folks in the audience have ideas, like please feel free to reach out, join the Discord, like tell me what you think would make this a better experience for you. Yeah.
Yeah. Makes sense.
That's Isograph right there, or that's like the current state of Isograph. Yeah. Okay. One thing that's really cool is you'll notice that, I mean, you're not actually providing any types. This is a very recent addition here. The fact that these types are all just like being piped for you. And another recent addition is that like you can actually just like directly render this thing. This was another thing that took a while to figure out, and but now that it works, it's like, it's quite nice, I think. So yeah.
It's it removes a lot of the usual boilerplate from like spreading a fragment, rendering component that makes use of that fragment and declares it. So I think this is really, really nice compared to other libraries.
Thank you.
That make use of. Yeah.
Yeah. Yeah. I mean, that's what I wanted to show off. So, cool. Thank you so much.
Thank you for sharing.
Yeah, no, thank you for taking the time and holding my feet to the fire and making sure I actually explained things. So,
no, it was super clear and super exciting. So yeah.
Excellent.
Looking forward to what comes next.
Yeah. Join the Discord, start the repository, try it out. Let me know what you like, what you don't like. We're here to fix the issues that people run into. All right, y'all.